Hello all, let us look at this question given in GATE 2019. Let G be an arbitrary group. Consider the following relations on G. There are two relations R1 and R2. R1 is for all A comma B belong to G, A R1B if and only if there exists an element G belonging to capital G such that A is equal to G inverse BG. R2 is for all A comma B belongs to G, A R2B if and only if A is equal to B inverse. Which of the above is or are equivalence relation or relations? The NPTEL video reference is Module 1 Lecture 2 on Functions and Relations. Course name is Real Analysis by Professor S. H. Kulkarni from IIT Madras. Let us look at the useful data before solving the question. Now let us look at what is a group. A group is nothing but it is a set G together with a binary operation. Let's say star is the binary operator and it's a function which is takes the Cartesian product. So G cross G means every Cartesian pair of G is the input and the output is an element in the set G itself. So G cross G giving G. So if you take two elements A comma B from G and apply the binary operator star, it should give me an element in G. Now a group must satisfy the following conditions. First, it should be associative. So for all A comma B comma C belong to G, if I apply A star B and then followed by C, or if I apply B star C and then A followed by A, it should be the same. G2 is the existence of a neutral element. There exists an element E belonging to capital G such that if I apply the binary operation star on A and E, it should give me the value A itself, or it's an identity element. Existence of inverses. Now there exists an element A prime belonging to the capital G such that if I apply the binary operator star on A and A prime, it should give me E back. E is the neutral element. And what is equivalence relation? Equivalence relation is a relation that is reflexive, symmetric and transitive. Reflexive meaning A is related to A should be true. Symmetric means if A is related to B, then B should also be related to A. Transitive means if A is related to B and B is related to C, then A should be related to C. Now let us solve the question. Let us look at R1. So R1 is what is written that for all A comma B belonging to the set capital G, A R1B if and only if there exists an element small g belonging to capital G such that A equal to G inverse BG. Now let G equal to E. Let G be the E where E is nothing but the neutral element. E always exists in a group. So if you look at the condition that we saw, E should always exist in the group. R1 is reflexive. Let us say how. Reflexive meaning A R1A should be true. Now if I write A instead of B A, then it will be A equal to E inverse AE where G is nothing but E. Now we left multiply with E. Okay, and E inverse will be as we saw in the previous slide, it's the inverse, so it should give me E back, right? And then E, we are right multiplying with E inverse so that this term becomes identity. Okay, so A is nothing but EA E inverse. Okay, which is A is EA E inverse. Okay, so the relation is reflexive. Now let us look at symmetric. It is symmetric. Let us see how. A related to B meaning A equal to G inverse BG for some G. B equal to G A G inverse. If we do the same calculation that we did before, we will find this. Now we can write G as G inverse of inverse A G inverse. And if G exists in the group capital G, according to the third condition, G inverse also must exist. Right? So R1 is symmetric. R1 is also transitive. Let us see how. Now A related to B and B related to C meaning A is G1 inverse BG1 and B is G2 inverse CG2 for some G1 G2 belonging to capital G. So we can write A substituting B as A is G1 inverse G2 inverse C G2 G1, and we can write G1 inverse G2 inverse as G2 G1 whole inverse C G2 G1. Okay. Now if G1 belongs to G and G2 belongs to G, the definition of group would say that G2 G1 or G1 G2 should also belong to G. Since the group is closed, so A is related to B and B is related to C, meaning A is related to C, and it is transitive. So R1 is an equivalence relation. It is reflexive, symmetric, and transitive. Let's look at R2. R2 says for all A comma B belong to G, A R2 B if and only if A is equal to B inverse. R2 is not reflexive. Let us see how. Reflexive meaning R2 A equal to A inverse. So for all A, it may not be true for a group that A inverse exists. Okay. Therefore, R1 is an equivalence relation while R2 is not. So the correct answer to this question is option B, R1 only. So I hope you all get it. Thank you.